Allocative efficiency. Allocative efficiency measures whether resources are allocated to those goods and services demanded by consumers. There is allocative efficiency when scarce resources are used to produce a set of goods that satisfies consumer preferences and maximizes their welfare. Now observe this diagram. In figure 1, two markets are shown. In the wheat market, current output is 0B. Now let's consider the wheat market. So in the wheat market, the current output level is OB or 0B. The market price is $1 because the government subsidizes production. In the electricity market, the output is 0E. The price is $6. The price is $6. But electricity suppliers receive only $4. So these electricity suppliers are receiving only $4. For instance, because the government imposes $2 tax per unit. So the reason behind this is because of the $2. The difference between 6 and 4 is 2. In the wheat industry, price is below marginal cost, where price is lesser than the marginal cost. This means that the value that consumers place on the product is less than the cost of producing the product. Consumers value the last unit produced at OB at $1. Consumers value last unit produced at 0B at $1. $1 is shown by the demand curve. The cost of producing the last unit is $3. So the cost of producing the last unit over here will be $3. Therefore, consumers value the last unit of wheat purchased at $2 less than its cost to produce. Now look at the electricity market. In the electricity market, price is above marginal cost. Price is greater than the marginal cost. This means that the value consumers place on the last unit produced is more than the cost of production. Now, when you observe these two diagrams, you can clearly see in the wheat market, the cost of production is much more. They couldn't even cover the cost of production in comparison to the electricity market. So consumers in the wheat market are paying less than the cost of production of wheat. Whereas in the electricity market, the consumers are paying higher than the cost of production of electricity. Consumers value the last unit. Produced at OE. Let me take this over there so that you can have a clear idea. So now you can see consumers value the last unit produced at 0E at $6. So they're paying over here at $6. While its cost is only $4 over here. Hence, consumers value the last unit of electricity purchased at $2 more than its cost of production. This suggests that scarce resources would be more efficiently allocated if less wheat and more electricity were produced in the economy. But how much wheat and electricity should be produced? If price is equal to the marginal cost in both markets, P equals MC, then consumers value the last unit consumed of both wheat and electricity as much it costs to produce those commodities. If price of wheat in figure 2 was $2 and electricity $5, then it would be impossible to reallocate resources between the two industries to the advantage of consumers. Productive efficiency. Productive efficiency exists when production is achieved at a lowest average cost. Now observe this diagram. This can be illustrated on an average cost curve diagram. According to the figure, it shows the average cost for a firm. It is productively efficient if it is producing 0A at an average cost. So it becomes more efficient at 0A. So that is exactly at this point. If it produces at 0D at an average cost of OF, so if it's going to produce at this particular point of OF and OD, where is OD? Over here. Right? So if it's producing at 0D at an average cost of OF, it's productively inefficient. So this point is showing that it is inefficient. This yellow point shows that it is efficient. Producing too much because OF is not the lowest average cost possible. The same argument applies if it produces at output 0C. So if it's going to produce at this particular level 0C, that is over here, it has the same argument, an average cost of OF. Yeah. There will also be productive inefficiency if the firm produces within its average cost curve boundary. If the firm is operating at point H, so if it's producing at point H, that is over here, this point, then output is 0B. So output becomes 0B. And average cost is OG over here. Then output of 0B and average cost of 0G, it is then productively inefficient. So this also shows that the organization is inefficient, and there are two reasons that they give. First, at point H, it is not achieving the lowest average cost as possible. So this is not, this point doesn't represent the lowest average cost. So we cannot consider this point as efficient. And then secondly, even if it was producing on the average cost boundary, production of 0B would be too low. 0B would be too low because you can see 0A is the maximum that this organization could produce at the lowest average cost. So you can see we are talking about two types over here, productive efficiency, which is at 0A and at a cost of 0E, 0A of output with 0E of average cost. Whereas there is inefficiency in the green part, where the organization is producing at 0D of output, whereas the cost is 0F, so which is higher than the efficient point. Now let's see, what does dynamic efficiency mean? There is dynamic efficiency in an economy when resources are allocated efficiently over time. So what does productive and allocative efficiency talk about? Productive efficiency talk about producing the goods and services at its lowest cost, whereas allocative efficiency talks about how the resources are efficiently used or utilized in order to produce goods and services what exactly the consumers are demanding for. So in contrast are examples of static efficiency. This is efficiency at a point in time. So an example that they had given about dynamic efficiency, the concerns of the rate of investment. So firms invest either to cut cost or to make new products. And also they invest on research and development. They invest on machinery, buying, building, and even on training workers. The rate of investment by firm is determined by a number of typical short-run considerations such as levels of demand in the economy, interest rates, and their past profitability. So dynamic inefficiency also could occur. So when it occurs, if firms fail to take into account of all the future cost and benefits of investment. For example, suppose if you have taken a loan from a bank, from a financial institution, you should consider that you need to pay back the interest. With research and development, which can take a very long time before the investment is repaid, firms may take no account of revenue to be received after, say, 5 years because they regard these benefits as too uncertain. So once you invest on research and development, we do not know how successful the product is going to be. If it's successful, yes, you succeed and it becomes a dynamic efficiency. If it doesn't become successful, it is called as dynamic inefficiency because you have used nearly 5 years in order to do research and development, and ultimately it is not bringing in enough demand for your product. Therefore, your sales drops, your profit will drop, therefore it will lead to dynamic inefficiency. But if all firms do this, there will be underinvestment in the economy as a whole in long-term research and development. This will reduce the socially optimal rate of technological change over time and hence reduce the pace of innovation. So when organizations are investing on research and development, it should ensure it is in line with the innovation or technology which is currently changing in the market. With the training of workers, firms may choose to attract workers from firms that have good training programs for their workers rather than increase their cost by training workers themselves. So instead, organizations training their workers, they get trained people so that it's easy and it'll increase efficiency. If all firms do this, then what happens? It will become dynamic inefficiency because every firm is expecting that the workers should be already trained. So if all organizations in an economy expect this, it might lead to dynamic inefficiency. Now observe this figure. This figure shows the effect of dynamic efficiency on the long run average cost curve over time. Now you can see, according to this diagram, your long run average cost is dropping. LRAC1 relates to one period of time and LRAC2, the green one, represents for another period of time. For example, LRAC1, the red curve, could be for 2010 and LRAC2, the green curve, could be for 2018, assuming dynamic efficiency has taken place. Now let's see, what does X inefficiency mean? It is sometimes also referred to as organizational slack in a specific type of productive inefficiency. So when does it occur? It occurs when a firm is not producing at the lowest possible cost for a given output. X inefficiency is present when a firm is operating with its average cost curve and not on the boundary. So here we are looking into the difference between the actual average cost curve and the possible average cost curve. Now, let's look at this same diagram that we were going through before. So I'm going to consider figure 2. So they're talking about figure 2. Let me take figure 2 over there. Right. X inefficiency is present when a firm is operating within its average cost curve and not on the boundary. This is the difference between the actual average cost curve and the possible average cost. In figure 2, now observe this figure which is on your left side. If a firm is producing at 0B, but its average cost is 0G. So if the firm is producing at 0B, that is here to here, and its average cost is 0G, average cost is 0G over here, then it's X inefficient because it is operating within the average cost boundary. In contrast, if it produces at 0C and its average cost is 0F, so let's look into that point, which is 0C to 0F, this point, then there is no X inefficiencies. Why? Because now they're able to produce within the average cost line. But the previous one, which I was showing you, that is this point, they are not producing on the average cost curve. In contrast, if it produces at 0C and its average cost of OF, then there is no X inefficiencies. So here there is no X inefficiency, right? There isn't X inefficiency, but over here, yes, there is X inefficiency. However, the firm is still productively inefficient because it is not operating at the lowest point on its average cost curve. So that the lowest point it should produce is exactly at this particular point, which is 0A of output. So X inefficiencies can occur for a large number of reasons. One is the example. Now you should know what are the examples of X inefficiency. So the examples they have given where the management of a firm is poor in controlling its cost. It may not pay the cheapest possible prices for its suppliers. It may employ too many workers or have too many production sites. It may employ most efficient and profitable capital, not employ most efficient and profitable capital equipment. So these could be some examples of X inefficiency. Efficiency and production possibility frontier, or we call it production possibility curve. The various concepts of efficiency can be illustrated using a production possibility frontier. A production possibility frontier shows combination of goods that can be produced if all resources were fully utilized. So in this example, you can see they had given a combination of products such as food and all other goods. Any point on the boundary in figure 4 is productively efficient. So if we take productively efficient point, we can see A, B, and C. All of them are productively efficient. Points A, B, C, and D, for example, are productively efficient. This is because each point shows the maximum output combination of goods that could be produced. If there were inefficiencies in production, then the firm or the economy would produce within the PPF say at E. So suppose if it doesn't produce efficient, it's over here, which we call it inefficiencies. If there is allocative efficiency, then production must take place on the boundary. On the boundary means on top of the red curve, the PPF curve. If production took place at E, it would be possible to have more food and other goods. This would benefit consumers. Hence, E is allocatively inefficient. So point E is allocatively inefficient. However, there is one point on the boundary that is allocatively efficient. This is the point where the preferences or utility of consumers are maximized. It is a point where the right combination of goods is produced to maximize the satisfaction of consumers. So those are the points they talk about A, B, C, D. Now we are going to draw the curves for perfectly competitive market, and we're going to show how a firm is gaining abnormal profit. So first of all, let's draw the marginal revenue curve. Then we are going to draw the average revenue curve on top. Now, let's mark a point where we're going to have the lowest point of the average cost curve and make sure it's below AR, because we are drawing for supernormal profit where your average cost should be lower than your average revenue. So we're going to draw supernormal profit. Therefore, your average revenue should be greater than your average cost. Now, let's construct the average cost curve. Now we know the lowest point of the average cost curve. Now, keeping this in mind, we can construct the marginal cost curve, which moves through the average cost, the lowest point of average cost. Now, let's mark this as marginal cost. Now, let's recap the rule. Marginal cost should equal marginal revenue. Identify that point and then draw the dotted lines all the way up to down, where it connects from the red curve, AR curve, towards the output. Now identify the points where AC cuts the dotted line as F and dotted line which cuts AR curve as E. Now draw the dotted lines towards E and from F and mark it as B and G. Now we had identified the abnormal profit or the supernormal profit. The area BEFG.